Let's solve this rational inequality. Now, as soon as I see this greater than or equal to sign, I know it's going to be one of those problems where we graph our solution set on a number line, starting with some critical values, and then doing test values to see where the solutions are. But how do we find those critical values that go on the number line? Well, the critical values come from two sources. One source will be any excluded values. For example, looking at this denominator, we know that x cannot equal positive 1. That means positive 1 will be on the number line as a critical value. Looking at this denominator, setting that equal to 0 tells us that x cannot equal positive 3. So these two values will be on the number line. We can also get additional critical values by solving the related equation that you get by replacing this inequality with an equal sign. So I'm talking about the equation 8 over x minus 1 equals x over x minus 3 minus 1. And I'm just going to go ahead and make a fraction because I know I'm going to need one in a moment. So the way I like to solve equations like this is I like to make all the denominators the same. So I have an x minus 1, but this denominator has an x minus 3. So if they're going to be the same, they're both going to need an x minus 3. I can put an x minus 3 in the denominator as long as I also multiply the numerator by x minus 3. Now, the next denominator has an x minus 3, but it lacks an x minus 1. So I can make them the same if I multiply by x minus 1 in the denominator and also the numerator. The final number, fraction, has no denominator at all right now. Technically, I could think of it as a 1. But anyway, I can make this denominator the same as the others by putting in both of these factors. So x minus 3 and x minus 1. So once you have the denominators the same in this way, oh wait, I put these in the denominator. I also must put them in the numerator. Of course. And again, this makes sense because this was a 1, and now here I have something divided by itself, which is also just 1. That's why it's legal. Anyway, once I have the denominators the same, I can cancel out those denominators like this. Now I can make a new equation based on the numerators. So this is going to be 8x minus 24 is equal to x squared minus x. Now I'm going to need to distribute this negative 1 throughout, but I can't do it while I still have a binomial times a binomial. So I say let's go ahead and get the trinomial from this first. So let's see, minus. So what I'm going to have for a moment is still going to be in parentheses. So I need to double distribute this. So x times x, that's x squared. X times negative 1, that's negative x. And then I'm going to distribute the negative 3. So that's going to be negative 3x and positive 3. So I have this. So that gives me x squared minus 4x, all right, just combining these like terms, plus 3. Notice how I left all this in parentheses. So that's what you have to do when there's a minus sign hanging out there, or even any other number. Like say this was a 5. I would need to multiply these, keep it in parentheses, and until you can then distribute. So now I'm going to take this, and I guess I might as well have left it as a negative 1, because now I'm going to take this negative 1 and I'm going to distribute it throughout. So this is going to give me minus x squared plus 4x minus 3, just changing all the signs here. Alright, I'm looking for like terms to combine. I'm seeing this x squared and this negative x squared. They cancel each other out completely. I'm seeing the negative x and the positive 4x. That's going to make positive 3x. So I'll have 8x minus 24 is equal to 3x, and then the minus 3 comes down. I only see one kind of x, just a plain x, no x squared. So I'm not going to get 0 on one side. Instead, I will get my x's on the left and my constants on the right. So I'm going to subtract 3x from both sides. So I get 5x minus 24 is equal to negative 3. And then I will add 24 to both sides. So that's going to give me 5x is equal to 21. Alright, time to divide both sides by 5. Now 5 does not go into 21 evenly. So all I know is that x equals 21 over 5. So this is my other critical value, 21 over 5. Okay, so x equals 21 fifths. So these three values need to go on my number line. Alright, to know exactly where they go in relation to each other, it would be helpful to have a decimal value for this. So let's see, 21 fifths, that's the same as 21 divided by 5. So that's 4.2. So just keep in mind that this is the same thing as 4.2. Alright, just so I have plenty of space, I'm going to graph my number line up here. So here we go. Alright, I have three critical values, and they happen to be in order right now. So here I go. I've got 1, and I've got 3, and I've got 21 fifths, which is the same thing as 4.2. Okay, now remember, excluded values, these green ones here, are always graphed as open circles, which makes sense because an open circle means that this point is not to be included in the solution, and of course we're not going to include values that are excluded. They're illegal. On the other hand, the solutions that come from the equation that we just solved sometimes are open circles, sometimes they're closed, depending on whether we have just greater than or whether we have greater than or equal to. This will be open circle, this will be closed circle, because this value that we found is the value that makes the function equal on both sides. We put an equal sign in here. So if we want to include the value that makes the function equal, we'll show that with a closed circle. But if it's just greater than, then we don't want to include the values that make the function equal, just the values that make the function greater, in this case on the left-hand side. So this, I see we have greater than or equal to, so we want to include the value that makes the function equal, and that's what this is. So we're going to show that we're including it by making it a closed circle. Okay, so here's where we do our test values in each zone. So over here to the left of 1, this is going to be f of, so I could use anything less than 1, 0, -1, -2. I'll just do 0. In between 1 and 3, an easy value to choose would be the number 2. Now in between 3 and 4.2. I'm going to use the value 4, but I could have used 3.5 or something like that. Now here I just need something bigger than 4.2. I'm going to go ahead and use 5, but I could have used 6 or 7 or 100. So these are the test values that I'm going to use. Now, problems like this are tricky because of the way there are variables on both sides of the inequality. So here's the technique that I recommend as far as checking the test values. I would transform this equation into a new equation where we have 0 on one side. You can do that in one step, just using your imagination. But basically, I'm going to take this and subtract it from both sides, so it'll wind up moving over to the left. And I'm going to take this -1 and I'm going to move that over to the left. So when I subtract these things, or add them in the case of the -1, when I move them to the other side, they're going to change signs. So the equation will become x over x minus 1, and then minus x over x minus 3. And this is going to become a plus 1 on the other side. And then I have my greater than or equal to 0. This is what I recommend that you do anytime you have a variable on both sides. Just get everything on one side, get 0 on one side. It's going to make it much easier to compare using our calculator, because now we're just comparing to are they greater than or equal to 0. So I'm going to put this function now into my calculator using the table feature. So 8 over x minus 1 minus x over x minus 3 and then plus 1. Alright, make sure you're in Ask X mode. Okay, and the values that we want to test are 0 and 2. I'm just going to do those first. So 0 and 2. So far I've got -7 and 11. Alright, so I've got -7 and 11. And we want to know, is the function greater than or equal to 0? So is this greater than or equal to 0? No, that's a negative number. It's less than 0. What about this? Is this greater than or equal to 0? Yes, it is positive. So that's yes. Okay, now let's check out 4 and 5. Alright, so I have -1/3 and 1/2. Okay, is -1/3 greater than or equal to 0? No, that's a negative number. Is 1/2 greater than or equal to 0? Yeah, 1/2 is greater than 0. It's positive. Alright, so the yeses show us where the solutions are. Alright, so apparently there are solutions here between 1 and 3. And there are solutions here to the right of 4.2. Okay. So let's write our solution set in interval notation from 1 to 3, and we'll use round parentheses to show that the 1 and the 3 are not to be included. And then union, and now this time I'm going to use a square bracket. Alright, this point is to be included, so 21 over 5 with a square bracket to positive infinity. So that is our solution set in interval notation. So comparing this to the solutions that were given, it looks like the answer matches choice D. So the answer should be D.